Hello and welcome back to AP Psychology on Educator.com. In this segment, we're going to be taking a look at visual processes, how the eye works, how waves get changed into electrical energy so the brain can understand it, and how our eyes can deceive us. Objectives from the College Board: describe the sensory processes. We're going to focus on vision here, and looking at energy transduction, the relevant anatomical structures, and the specialized pathways to the brain. We're also going to be looking at some of the common sensory disorders that we've got. Now, what can we see? I'm assuming that as you're looking at this screen, you can see those two large black circles in your field of vision, right? Two large black circles. I can see you through the camera. You're looking at me like I'm crazy. But the fact of the matter is that there are two large black circles. And as a result, your brain doesn't like it. And so what happens is your brain fills in the blanks. And you don't notice it. Now, have you ever heard of a blind spot? If you have, that's essentially those two large black circles. Because at the back of the eye, where all the cells go and the information goes to the back of the eye, goes into your optic nerve. Your optic nerve, there's this little thing called an optic disc at the back of your eye. You can't see there. And so we all see these two large black circles, but the reality is that our brain says, I'm not having that. I'm going to fill in the blanks. So we don't always necessarily see what we think we're seeing. And did you know that our vision is upside down, blurry, and riddled with black splotches? We don't see clearly now, even though the rain is gone. We see blurry. It's terrible. But our brain cleans it up. Our brain is kind of nice that way. Vision. What can we really see? Can we really see each other? Now, when I'm in my classroom and I ask my students, can you see each other? Of course they say, yes, we can see each other. I'm looking right at my person here. I'm looking right at my friend, my partner, whatever it is. But the reality is we can't see each other. All we see is light waves reflecting off of the molecules that make up who we are. So you're not seeing me. You're seeing a video representation in 2 dimensions that has been electronically captured, sent over a series of tubes called the interwebs, a series of both electronic landline as well as satellite information, and you have a representation of me. You can't actually see me. Even if you were standing here in this room with me, you couldn't see me. And I'm not talking about John Cena, you can't see me. I'm talking about you can only see light waves bouncing off of my molecules. And so when we think about vision, we need to know that light comes at us in waves as part of the electromagnetic spectrum. And this is going to be true for vision, hearing, and touch, the energy senses with the electromagnetic spectrum. Wavelength is going to be one word that we need to know, and that's going to be the distance from one wave peak to the next. So we've got sine waves, and so the peak is right here. I'm going to change colors here. The peak is right here. Peak is right here. What is this distance right there? That's going to be wavelength. Hue is going to be the color that we experience. Blue. Why don't I make it blue? Blue. Green. Red. But how do I know that my blue is the same as your blue? How do I know that my green is the same as your green? How do I know that my red is the same as your red? I'm not completely convinced that we totally experience the same identical versions of those colors. And have you ever noticed that cultural considerations here, that guys don't have as many vocabulary words to describe different kinds of colors? How many guys outside of San Jose and the San Jose Sharks know what teal is? How many guys know what chartreuse is or taupe? Women in general tend to have a better color vocabulary than men do. And so color is hue. And then intensity. And that's going to be the amount of energy in the wave. And that's going to be measured by amplitude or height. Amplitude or height of the wave.